Hello friends, in this video we will learn about plane mirror. So this video comprises following things: plane mirror and the properties of image formed by plane mirror. We will learn the properties of plane mirror, and under this section we will learn deviation produced by plane mirror, the deviation produced by two plane mirrors. If we rotate a plane mirror, then what will be the effect on the reflected ray. We will see the image of watch in plane mirror. We will see the image formed by two inclined plane mirror. That is how on changing the inclination of plane mirrors the number of images changes. We will see the speed of image in plane mirror. Like if we move the object, we will move the mirror, then what will be the impact on the speed of image. We will see some other properties of plane mirror also in last. So please subscribe it, like it, share it, and press the bell icon. Please comment on the video. Your comments are very valuable to us. Thank you and keep watching. Coming to our first part of this video, and it is the plane mirror. So what is basically plane mirror? How will be the image of plane mirror? We have already learned about plane mirror. Now we will learn the properties of its image. So image formed by a plane mirror is virtual, erect, laterally inverted, that is sideways inversion, equal in size of the object. So it's clear here, the image formed by plane mirror will be virtual. So if you see here, this is the image formed by the plane mirror, and this image is the virtual image. As if you see that the light ray actually does not meet at this point. The light ray reflects from this plane mirror and hits the eye. So in turns it seems that the light ray is coming from this image. So light ray actually seems to diverging from this image, and because of this image is a virtual image. We have already learned that if the light ray converges at any point, then it is called as real image, and if the light ray seems to diverge from that point, then it is called as virtual image. So the image formed by plane mirror is a virtual image. It is erect image, it is not inverted. So if I say the image of A in the plane mirror, then we see the image in this way. If the image will be inverted, then the image of it will be like that. So this is the difference between erect image and inverted image. So the image formed by plane mirror is virtual and erect, afterwards laterally inverted. What is meaning of laterally inverted? It's a left right reversal. So in the plane mirror you may see your left hand seems to be right hand, while your right hand seems to be left hand in the mirror. So we call it lateral inversion, that is left to right and right to left, and we also call it sideways inversion. Again, the size of image in mirror is equal to size of object. So all those things you can learn in your day-to-day life. So this is the example of lateral inversion. If I place R in front of plane mirror, we will see a sideways inverted R, and the distance of this image is at the equal depth as the distance of object in front of plane mirror. So its second concept is distance of image equal to distance of object in front of the plane mirror. So this is shown here. If you see this figure, light ray is not traveling through the path inside the mirror. So this is our mirror, and the light ray starts diverging from the object. It hits the plane mirror and eventually it hits our eye. So actually light ray is not going inside the mirror. So that's why this light ray is shown by dotted lines. Clearly dotted lines show you that it's a virtual image. So here it's written as virtual image means light ray diverges from the image, and it is shown here. The magnification produced by plane mirror is equal to image height divided by object height, and if you see here, image height is equal to object height, so magnification is equal to 1. Now we will see different properties of plane mirror. So first we will learn the deviation produced by plane mirror. So it is shown here. If you see this figure, then this is our mirror, and angle of, for the angle of incident I, we get angle of reflection R. So as I is equal to R as per the law of reflection, so deviation here is, deviation is equal to 180 degree minus I minus R, that is equal to 180 degree minus 2I. So clearly deviation produced by plane mirror is 180 degree minus 2I. The deviation means by how much angle the incident light ray has been deviated. So here the angle deviation produced by plane mirror is 100 to 80 minus 2I, and if the angle of incident is equal to 60 degree, then the angle of deviation is equal to, again angle of deviation is also equal to 60 degree, because delta is equal to 180 degree minus 120, that is equal to 60 degree. So deviation, when we will observe maximum deviation occurs when we have a normal incident. Consider the light ray when it comes or strikes the boundary normal to it, so it will reflected back in the same direction, and in this case the deviation will be 180 degree. So deviation will be maximum for I is equal to 0, we have R equal to 0 and it's normal incident. Similarly, the minimum deviation is approximately equal to 0 degree when we have angle of incident equal to 90 degree, almost equal to 90 degree. Like suppose that this is the surface, and if the light ray hits it making an angle approximately equal to 90 degree, then it will be reflected back in the almost in the same direction, and in this case we observe the minimum deviation, that is almost equal to 0 degree. So here we have learned the formula of deviation. Delta is equal to 180 degree minus 2y, and the maximum deviation for normal incident, and it is equal to 180 degree. The minimum deviation is 0 degree for I is equal to 90 degree. Now we learn the deviation produced by two plane mirrors. So if two plane mirrors are inclined at an angle theta, then the incident light ray and the emergent light ray after two reflections make an angle 2 theta with each other, and in this case the deviation produced by two plane mirror will be equal to 360 minus 2 theta. So all things are shown here. If you see this figure, then as per this figure the incident light ray is this one. So this is basically our incident light ray, and this is our emergent light ray. So if you see that the incident light ray and emergent light ray are making an angle 2 theta, which is shown in this diagram, and in this case the deviation produced by two plane mirror after reflection will be equal to 360 minus 2 theta. So we will not give proof of this, it's just a concept, you should know it, and you just apply this concept while solving the problem. So consider the case when theta is equal to 30 degrees. So in this case the deviation produced by two plane mirror will be equal to 360 minus 2 into 30, that is 300 degree. Similarly, if we consider theta is equal to 60 degree, then deviation produced is equal to 360 minus 2 into 60, that is equal to 360 minus 120, and it is equal to 240 degree. So now there comes an interesting case when the two plane mirrors are inclined to each other at an angle 90 degree, and in this case we see that the emergent ray is anti-parallel to incident ray if it suffers one reflection from each mirror. So it is shown here. If two mirrors are this way, suppose this is the mirror M1, this is the mirror M2, and the angle between these two mirrors are 90 degree. Now if the incident light ray strikes the first mirror, then it goes to the second mirror, reflected from that mirror also, and the final emergent ray E and incident ray E, if you see they are anti-parallel to each other, that is they are making an angle 980 degree with each other. So if you do calculations, then delta is equal to 360 minus 2 theta, and here theta is equal to 90 degrees, so it's equal to 360 minus 2 into 90, that is equal to 180 degree. So two plane mirror, if they are inclined to 90 degree, then the emergent ray is anti-parallel to incident ray if it suffers one reflection from each mirror. And this is the very important concept from objective problems. Now we will see next concept. And next concept is the image of watch in mirror. So if real time of watch is A hours, B minute and C second, and if this time is less than 11 hours 59 minutes and 60 seconds, then the time as seen in the image of watch in a mirror will be the 11 hour 59 minutes and 60 second minus A hour, B minute and C second. So basically if the time is less than 12 o'clock, then if you see the watch in the mirror, then the image of watch is simply the subtraction of real time from 11 hour 59 minutes and 60 seconds. So this is also important concept and problem has been asked in the examination. So a problem is based on this concept. An unnumbered wall clock show time 4 hour 25 minute and 37 second, where first term represents hour, second term represents minutes and last term represents second. So what time will its image in a plane mirror? So how we will solve this problem? So time in plane mirror is equal to 11 hour 59 minute and 60 second minus 04 hour 25 minute and 37 second. So if you solve it, then 60 second minus 37 second, and it comes out to be 23 second. Now subtraction of minute, then 59 minute minus 25 minutes, so it comes out to be 34 minute. And in hour, if I subtract 11 hour minus 4 hour, then it comes equal to 7 hour. So if you see this clock which is showing the time 4 hour 25 minute and 37 second in a plane mirror, then in mirror the time seems to be 7 hour 34 minute and 23 second. So you will solve any problem based on this concept. Like suppose the time is 3 hour 27 minute and 32 second, then you have to calculate what time its image in the plane mirror. So simply do the subtraction from 11 hour 59 minute and 60 second minus 3 hour 27 minute and 32 second, and from there you get 28 second, and here 32 minute and 8 hours. So the time which is shown in the plane mirror will be 8 hour 32 minute and 28 second. So in this way we can solve the concept of image of watch in mirror. Now we will see the next concept, and now we will see rotation of reflected light in plane mirror. So we divide this into three parts. First is the rotation of plane mirror keeping the incident ray fixed, and second is the rotation of incident ray keeping the plane mirror fixed, and in the third section we will rotate both incident light ray and plane mirror. So first we will see rotation of plane mirror. So it is shown here. Here if you see a incident light ray is reflected making an angle I is equal to 0, and then you will see reflected light ray is also making an angle R equal to 0. Now we will rotate the mirror by angle theta in anti-clockwise direction. So if you rotate the mirror by angle theta keeping the incident ray fixed, then the normal will also be shifted or rotated by an angle theta. So now the incident light ray is making an angle theta with the normal. Clearly the reflected light ray is also making angle theta, and in this scenario the reflected light ray is shifted from angle 0 degrees to angle 2 theta. So clearly the reflected light ray is rotated through an angle 2 theta in the same direction. So it's all things are written here. If a plane mirror is rotated in a plane of incident through an angle theta by keeping the incident ray fixed, then the reflected ray turn through an angle 2 theta. And this is equally true when the light ray is making an angle theta with the normal direction. So this is, suppose this is a plane mirror, and this is our incident light ray which is making an angle alpha with the normal. So the reflected light ray is also making an angle alpha. Now suppose we shifted the mirror by an angle theta. So if we shifted the mirror by an angle theta, then the normal will also be shifted by an angle equal to theta. So now the new incident angle I nu is equal to alpha plus theta, new reflected angle R nu is equal to alpha plus theta. So the new reflected angle will make from this line alpha plus theta. So this is our new reflected light ray. So the new reflected light ray is making a net angle equal to, earlier it was making an angle alpha, so R old is equal to alpha and R new is equal to alpha plus theta with respect to its new normal line. So with respect to its old line, with respect to old normal line, is equal to alpha plus theta. So it's equal to alpha plus 2 theta. So clearly if you see that R new with respect to old normal and R old with respect to old normal is having a difference equal to 2 theta. So the reflected light ray turned through an angle 2 theta in the same direction. Now we'll see the rotation of incident angle. So if the incident ray is rotated by angle theta, then the reflected ray is also rotated by angle theta in opposite direction. So two concepts are involved here. First is the reflected ray is also rotated by angle theta, and second is it is rotated in the opposite direction. So it is shown here its boundary, and this is our normal line. Suppose that the incident ray is coming with making an angle theta with the normal, then the reflected light ray will also make an angle theta with the normal line. Now suppose that the incident light ray has been rotated by an angle alpha in clockwise direction, then if you see that new incident light ray is equal to theta minus alpha. So this is our new line, and this line is making an angle theta minus alpha. So clearly the reflected light ray will also be rotated by angle alpha, and now the new reflected light ray will making an angle theta minus alpha. So for angle of rotation equal to alpha in clockwise direction, we make the reflected ray rotated by the same angle alpha in the anti-clockwise direction, that is in the opposite direction. Similarly, if the incident ray is rotated by angle beta in anti-clockwise direction, then the reflected ray will be rotated by angle beta in clockwise direction. So it's clear here that if I make the angle alpha in anti-clockwise direction, then the reflected ray will rotated by angle alpha in clockwise direction, and if we rotate the incident ray by angle alpha in a clockwise direction, then the reflected ray will rotated by angle alpha in the anti-clockwise direction. So all things are written here. So if you see here that the incident ray rotated by angle theta clockwise or anti-clockwise, then the reflected ray will rotated by angle theta anti-clockwise or clockwise. So if you see the difference in order here. And second point is that if we rotate the mirror by angle theta clockwise or anti-clockwise, then the reflected ray will also be rotated by angle 2 theta in clockwise or anti-clockwise respectively. So rotation by mirror causes the rotation of reflected ray in the same direction, while the rotation of incident ray makes the rotation of reflected ray in different direction or in opposite direction. Now we'll consider third case, the rotation of both mirror and incident angle. So in this third case, we see that if the incident ray is rotated by angle alpha clockwise, so first thing is that we are making an angle alpha clockwise, then mirror rotate by an angle beta clockwise. So because of incident light ray, we will see reflected light ray alpha anti-clockwise, and for mirror we get 2 beta clockwise. So the net reflection, net angle or net rotation will be 2 beta minus alpha clockwise. So I think it is clear to you. Because of mirror we get 2 beta in clockwise, we get 2 beta, and because of incident light ray we get alpha anti-clockwise. So the net will be 2 beta minus alpha clockwise. So all those 4 cases are written here, that incident light ray alpha clockwise, mirror beta clockwise, we get 2 beta minus alpha clockwise. Now if incident light ray alpha anti-clockwise, then we get reflected light ray, due to it will be alpha in clockwise direction, so alpha in clockwise, and for beta rotation of mirror in beta anti-clockwise, then we get 2 beta rotation, so 2 beta, so the net will be 2 beta minus alpha anti-clockwise. So it's written here. Similarly, alpha clockwise for incident, mirror beta anti-clockwise, we get 2 beta plus alpha anti-clockwise, because for this we also get alpha anti-clockwise, for this we get 2 beta anti-clockwise, so net will be alpha plus 2 beta anti-clockwise. And if incident ray alpha anti-clockwise, mirror beta clockwise, we get alpha plus 2 beta clockwise. So I think it's very easy, you can easily understand it. Now we will move to next concept, that is image by 2 inclined plane mirrors. In this section we will learn that when 2 plane mirrors are inclined at angle theta, then how many images are formed. So for this we just take 2 cases. Like first case, if 360 by theta is even integer, then the cases will be different, and when 360 by theta is odd integer, then case will be different. So first case will, if 360 by theta is even, so if 2 mirrors are inclined by an angle theta and 360 by theta is even integer, then number of images formed is equal to 360 by theta minus 1. Like if you take theta is equal to 90 degree, then if you divide 360 by 90 degree, we get the value equal to 4, and 4 is an even integer, so number of images formed will be 4 minus 1, that is 3, and all 3 images are shown here. Suppose this is the 2 mirrors which are inclined at an angle theta is equal to 90 degree, and if an object is placed here, then you may see that here we have formed we observe 3 images, and this is our first image, second image, and third image is formed at the intersection of these 2 mirrors. So for angle theta is equal to 90 degree, it is shown here. Now consider the case when theta is equal to 60 degree. So when theta is equal to 60 degree, then 360 by 60, that is equal to 6, and 6 is an even integer. So as it is even integer, so number of images formed is equal to 5, and it is shown here. 2 images are formed each plane mirror, and 1 image is formed at the intersection of these 2 plane mirrors. So total number of images formed will be 5, and in this case we see that when the 360 by theta is even integer, number of images formed is 360 by theta minus 1. So clearly if we make angle theta smaller, then number of image formed will be increased, and in all cases one image is formed at the intersection of mirrors. So I think when the angle is formed such that 360 by theta is even, it is clear. Now we will see the case when 360 by theta is odd integer and we divide this section into two parts. If the object is placed symmetrically, then a number of images formed is 360 by theta minus 1. So what we will do, suppose the two mirrors are inclined at an angle theta, and if we divide this 360 by theta, we get an odd number. Then two cases are formed. First is if placed symmetrically. If placed symmetrically means the object is placed at the angular bisector or angle bisector of this angle. So symmetrical means the object is placed on the angle bisector line, and in this case we see that number of images formed is 360 by theta minus 1. Now if it is placed asymmetrically, so if placed asymmetrically, if the object is placed asymmetrically means object is not placed on the angle bisector line, that is this line, the object is placed on a line which is making an angle alpha and beta different from the both mirrors, then in this case the number of images formed is equal to 360 by theta. So we have learned this case also, that first is the 360 by theta even, then number of image formed is equal to 360 by theta minus 1, and 360 by theta is equal to odd number. Then if symmetrically placed, then it is equal to 360 by theta minus 1. If not symmetrically placed, then 360 by theta. And you may observe this also in your day-to-day life. You just put two plane mirrors and then place an object there, you will say a multiple number of images formed, and the number of images formed changes if you make if you change the angle between two mirrors. Again, the second point is that if nothing is said about the object, then we consider the object is placed symmetrically. So if nothing is said, object is supposed to be placed symmetrically. So suppose theta is equal to 72 degree, we observe 360 by 72 is equal to 5. It is an odd number, and as nothing is given, so symmetrically placed, so minus 1, 4, number of images formed is equal to 4. Now if we get the value of 360 by theta not integer, if we get decimal, like if theta is equal to 50 degree, then and considering the object as symmetrically placed, we get 360 by theta is equal to 7.2. So as it is symmetrically placed, so we apply the formula 360 by theta minus 1, we get 6.2. so the number of images formed is equal to 6. Images formed is not integer, then you take the greatest integer of that, like 360 by theta minus 1, and take the greatest integer, like integer equal or below than that number. So last case is that when theta is equal to 0 degree. Now consider the case when theta is equal to 0 degree, that is mirrors are placed parallel to each other, and in this case the number of images formed is equal to infinity. So these two mirrors are shown here, mirror 1 and mirror 2, both are placed parallel to each other and object is placed in between of it. Now if you see that for mirror 1 this image is I1, we call it I1, and for mirror 2 this image we call it equal to I2. Afterwards this I1 image serve as a object for mirror 2 having a distance equal to x1. Suppose this distance is equal to x1, and because of this we get an image equal to, we get this image at distance x1, and we call it this image as I3. We call it I3 subscript 2. So we call it I23. Similarly, this I2 forms a object for this mirror 1, and we get the image of this. We call it I4 2. So basically I1 and I2 are first order images, and this I3 and I4 are second order images. So as I3 and I4 are second order images, so we have shown it by red color or a different color. Now this I4 serve as an object for this mirror 2, and then an image will be formed. We call it I5 3, and this I3 2 will again serve as a object for this image for mirror 1, and the image form is equal to I6 3. So clearly I6 3 and I5 3 are basically a third order images, and we have shown it by the yellow color. So we have observed infinite image in a saloon if two plane mirrors are placed parallel to each other. So now we'll see next slide, and here a table has been drawn in which it's written as the angle between two plane mirrors and number of images formed. So if you see that when angle theta is equal to 0 degree, that is when the angle between two plane mirrors is 0 degree, two plane mirrors are parallel to each other, then whenever object is placed symmetrically or asymmetrically, number of images formed is infinity. Now for theta is equal to 30 degree, we get n is equal to 12. It's a even number, so whether it's symmetrically or asymmetrically placed, number of images formed is 360 by theta minus 1. So it's equal to 360 by theta minus 1. Now for 45 degree, theta is equal to 45 degree, again n comes equal to even number, so 360 by theta minus 1, number of images formed is equal to 360 by theta minus 1. For theta is equal to 60 degree, we see n is equal to 6 and number of images formed is equal to 5. For theta is equal to 72 degree, we get n is equal to 5. It is odd number, so whether object is depending on whether object is symmetrically or asymmetrically placed, number of images formed changes. So for symmetrically placed, number of images formed is 4, while asymmetrically placed, number of images formed is equal to 5. So for the symmetrically placed, we get the formula 360 by theta minus 1 for symmetrically, and for asymmetrically placed, number of images formed is 360 by theta. So for similarly for theta is equal to 90 degree, we get number of images formed is 3, and so on. Now we will learn next concept, speed of image in plane mirror, and it is also an important concept. We have observed that whenever we move in front of plane mirror, then our image also moves. So basically we will learn about this concept in this section. So when an object moves with speed u towards or away from a plane mirror, then the image also moves towards or away with speed u. Again, the relative speed of image with respect to object is 2u. So it is shown here like mirror is at rest, mirror is not moving, and the object is moving towards the mirror with an speed u, then image will also move towards mirror with an speed u. Again, if the object is moving away from the mirror with a speed equal to u, then image will also move away with a speed equal to u, and this mirror is at rest. Now consider the relative speed of image with respect to object. So relative speed of image with respect to object, and it is equal to speed of image minus speed of object, and it is equal to u minus u, that is equal to 2u, if we are considering the direction of velocity of image as positive. So it is written here, velocity, the relative speed of image with respect to object is 2u. Now consider the second case, when the object is stationary and mirror is moving with a speed u. So in this case the image will move with a speed 2u. It is shown here, the object is at rest, mirror is moving with a speed u, then image will move with a speed 2u. So how it is possible? I will just show you. Suppose this is the plane mirror. The object was initially placed at a distance x from the mirror. Now the mirror is moving with a speed u, so in 1 second the mirror will move at a distance equal to u. Earlier the image was formed at a distance equal to x. Now the image will be formed at a, now the new object distance is equal to x minus u. So new image distance will be equal to x minus u. So this is the new image. I just call it I1, call it I2, this is O. Now if you see here, the distance between both I1 and I2, so distance between I1 and I2, and it is equal to, this distance was x. So we will consider with respect to this line. So with respect to this line, it is at x distance, and this image is at distance, this image is at x minus u from this line. So with respect to this line, it is at, with respect to this line, it is at x minus u, that is equal to x minus 2u. So the distance between these two is equal to this one, and is equal to 2u. So distance between I1 and I2 is equal to 2u. So if mirror is moving with a speed u, then image will move with a speed equal to 2u. So it's written here, when mirror moves towards the stationary object with speed u, then image will move with a speed equal to 2u. So now if you combine these two cases, that is the movement of mirror and object, then if object moves with velocity v while mirror moves with velocity u, so here the velocity of mirror is equal to u and velocity of object is equal to v. So if both moves towards each other, so how we will solve it? We will consider the case of each and then add. So if both moves towards each other, then image moves with velocity v plus 2u towards mirror. So object is moving towards velocity v, so image will move with a velocity v towards mirror, and the mirror is moving with velocity u, so image will move with velocity 2u. So it is shown here, v due to movement of object and 2u due to movement of mirror. So net is v plus 2u towards mirror. Now if both moves away each other, so here the object is moving away with velocity v and mirror with velocity u. So clearly due to this movement of object, it is v away from mirror, and due to this mirror, it is also 2u away from mirror. So if we add these two effects, we get v plus 2u away from mirror. It is written here, if both moves away from each other, that image moves away with a velocity v plus 2u away from mirror. Now third case, if both moves in same direction. So if both moves in same direction, suppose this object is moving with velocity v in left hand side, or towards left, the mirror also moves with velocity u towards left, then we will learn effect of both movement. So due to the movement of object, the image will move towards right with velocity v, and due to movement of mirror, the object will move with velocity 2u towards left. So the net effect is 2u minus v towards left or towards mirror. So the net effect is 2u minus v towards mirror. Now we will see fourth case, when the object is moving with velocity v towards mirror, and that is towards right side. This mirror is moving with velocity u towards right side. Then we will see the effect. So so the image will move with velocity v towards the mirror, and in the second, due to the movement of mirror, it will move with velocity 2u away from mirror. So the net effect is 2u minus v away from mirror. The next concept is, a man of height h requires a mirror of length at least equal to h by 2 to see its complete image. Now consider a man is there. So suppose this is the man, and it has to see its own image. So you have to calculate the height of mirror, plane mirror required. So suppose this is the topmost point of its head, and this is his eye. So he will be able to see his head if the light ray after reflection from the mirror comes to its eye. So then he will be able to see its head, and in this case it seems that the light ray is coming from its head in the image. Now you have to see that what is the height of mirror. So for the light ray comes from his leg, so the light ray comes from his leg and it has to reach to its eye. So this is the light ray, and in this case what will happen is image at the bottom will be formed. So if you see this figure, then this point will be the middle point of this mirror, and as angle of incidence is equal to angle of reflection, so clearly if this angle is theta, then this angle is also theta, and this line, this is at h by 2. So if we ignore the length between head, and a mirror of length at least equal to h by 2 is required to see its own complete image. Now consider the case when man is standing at a different location. So we just first draw the figure. Then suppose this is the height of man. This is basically mirror, and the man is standing near the mirror. So this is basically our head, this is our eye, this is our head, this is our eye. Now the light ray goes from head, strikes the mirror and come to the eye, and in this case in the mirror the image is formed. From the feet, a light ray goes, strikes the mirror and comes to the eye. So, and in this case the image will be formed here, having this place as H, this place as E, and this point is the bottom point. So if you see here, that image is formed in this case. Now if the man is standing far behind it, so suppose this man is standing now at this location, this is head, this is eye, and this is his feet. So if I draw the diagram, then diagram will be like that only. So if I extrapolate it, we will see. So clearly in this case, image of man standing far from mirror. So this is image of man standing far from mirror, and this is object of man standing far from mirror. We term it O2. This O1 is the close to the mirror. So in both cases, if we see that if a man of height h requires a mirror of length equal to h by 2, no matters where it stays and what is the location of man with respect to mirror. So this is the basic concept. Now the next concept is standing at a distance x from plane mirror in front of him. He wants to see the entire wall of height h in mirror, which is at distance y behind the man. Then the minimum size of mirror required is. So first we will draw the figure pertaining to this, and then we will learn this concept. So suppose this is the man, and behind this man a wall of height h is there at a distance y, at a distance y. So you have to calculate this minimum size of mirror required. So suppose to in order to see this wall of height h, the first we will draw the ray diagram, and ray diagram will be like that. So this is his eye. The light ray comes, and after reflection from the plane mirror, it hits the man eye. Now we will see the foot of this wall and foot of the wall again in the similar way. It comes in reflected from this mirror and then hit its eye. So this is the minimum length of mirror required, and this is mm dash. So the formula for this height minimum size of mirror mm dash is equal to h into x divided by y plus 2x, where x is the distance of man from mirror and y is the distance of wall from man. Now consider the case if a person is standing in middle of mirror and wall, then to see complete wall behind himself, person requires a plane mirror of at least 1/3 of height of wall. That is, in this case, what you will do, you just put x is equal to y is equal to d, and in this way you will get mm dash is equal to h into d divided by 3d. It comes equal to h by 3. So the whole figure is shown here. From the top of the wall, a light ray comes. After reflection, it hits the eye, and from the bottom also a light ray comes and hits the eye after reflection. So in this way you will get the height of mirror is h by 3. A similar problem based on the above concept is shown here. Here a point source S is placed at a distance L from the center of plane mirror of width d, and a man walks parallel to mirror along a line at a distance 2L from it, the greatest distance over which he can see the image of light source. So if you see here, then a source is placed at a point S, and the man moves along a line parallel to the plane mirror and at a distance 2L from it. So you have to calculate the distance through which the man can see the image of light source. So the ray diagram is shown here. If you see from this figure, then HI is equal to AB and it is equal to D. So this is equal to D, and if you see this this triangle AGH, then this angle is theta, and from there we can write tan theta is equal to GH divided by AH. And again, if you consider this triangle ACD, then it is equal to CD divided by AD. So from this figure, this value is equal to d by 2. CD is equal to d by 2. So CD is equal to d by 2. From there we get d by 2 divided by L. So GH divided by 2L is equal to d divided by 2L, and from there we get GH is equal to d. So this GH comes equal to d. Now if you consider this triangle BIJ and do the similar exercise, as you know that EF is equal to d by 2. So EF is equal to d by 2, and if you do the same exercise, then you get IJ is equal to d. So IJ is equal to d, GH is equal to d, and HI is equal to d. So GJ is equal to DH plus HI plus IJ, and it is equal to D plus D, that is equal to 3D. So the man can see a maximum distance up to 3D, and he can see the greatest distance over which man can see the image of light source is equal to 3D.